All right, so good afternoon, everybody. Today is Friday, February 18th, 2022, and we're starting group data. Under group data, we need to know how to determine an estimate of the mean. And as we progress, you will see why in group data, the mean that you calculate is an estimate. And as I say, as we progress, you will see why the mean is called an estimate. So under group data, an estimate of the mean x bar is equal to the sum of fx divided by n. Now, fx stands for frequency times class midpoint. So class midpoint is another new term. And as I said, when we get into the example, you'll see what we mean by class midpoint and how important class midpoint is. So fx stands for frequency times class midpoint. This is still true. N is equal to the sum of the is equal to the sum of the frequency, and n is the number of values. Guys, the sum of fx is an estimate of the sum of all the values. So remember, whenever you calculate average or mean, which is the same as average, whenever you calculate mean, you'd have to add up all the values and then divide it by the number of values. So if the mean x bar is equal to the sum of fx over n, it means that the sum of fx must be an estimate of sum of all values and divide by n, which is the number of values. That is how you calculate mean or average. You have to add up all the values and then divide by the number of values. So since the bottom part n is the number of values, it means therefore that the sum of fx is an estimate of the sum of all the values. All right, and as we progress, you will see why we say it is an estimate. Under group data, you're going to come across the term class midpoint. And this, you're going to come across the term class midpoint, and this is how you calculate class midpoint. It's going to be the upper class limit plus the lower class limit divided by 2. I think what is actually in your notebook is minus the lower class limit, so just change that to a plus. It should be the upper class limit plus the lower class limit divided by 2. And when we do our first example, you will see what we mean by upper class limit and lower class limit. Guys, under group data, the class width or the class size, is the upper class boundary minus the lower class boundary. And again, when we do the examples, you'll see what we mean by upper class boundary and what we mean by lower class boundary. Under group data, the mode class is the class with the highest frequency. The mode class is the class with the highest frequency. Guys, on a group data, one of the first things we'll have to draw, we need to learn how to draw is how to draw a histogram and a frequency polygon when we're dealing with group data. All right, so at this stage, all I will say is that for the histogram, on the vertical axis, you have frequency, and on the horizontal axis, you're going to have the upper class boundary. All right, and again, you will see that in action when the time comes. For frequency polygon, when we're going to draw a frequency polygon, frequency is going to be on the vertical axis, and the class midpoint is going to be on the horizontal axis. This note is important, and when we are drawing a frequency polygon, I will repeat it. The frequency polygon opens and closes on the horizontal axis. It starts at one class width before the first class midpoint and ends at one class width after the last class midpoint. So again, that statement is important, and I will demonstrate and show you and show you what it means when we are going to draw a frequency polygon. All right, so next we're going to look at example 6.